Okay, guys, trapezoids and kites are really relatives of the squares and rhombuses. I mean, they're really related, guys. But they have a little twist to things, you know. They're unique, guys. Okay, so first of all, the sides are not congruent. Can you see it? I mean, sometimes they can be isosceles, but sometimes the sides can be totally different. They can have two bases which are parallel to each other. You can tell. So here the bases are really important, guys, especially to get stuff. An isosceles trapezoid when you have two equal sides. Can you see that? Then if you have two equal sides, then you have an isosceles trapezoid. So if two sides are the same, then the bottom angles will be equal to each other, and the upper angles will be equal to each other. Can you see that these two angles will be the same? If you have an isosceles, all you have to have is just an equal pair of legs. See that? And then you're in business. Okay, so that's an isosceles trapezoid. Okay. Now, if the trapezoid has one pair of congruent bases, angles, and so the bases are the same, then we will say that this will also be it can be, even if that's not, if these two are the same. Can you see that right there? Then these two angles will be the same. These two angles will be the same as well. Okay. And finally, guys, if a trapezoid is isosceles, the diagonal lines, these ones, will be congruent or equal to each other. So they're really just a little twist, guys, and it gets really interesting once you guys start using it. Um, and we will use it more in pre-calculus and once we go there and stuff like that. Okay, so let's work on this just a little. We need to prove x equals to 11 in this situation. So let me snip it just a little bit, and then we'll take it from there. Okay. Okay, and this one, guys, let me see. An example one, they give us a lot of information that we might not need, or we might need. So let's start with, let me see if we can get something in orange. And AB, this side AB, this little side right there is 3x minus 2. And they're talking only about sides right here. So that's pretty good. CD, guys, CD will be 3x plus 9. Okay. And then AD or AD or DA is 4x plus 5. And BC will be 5x minus 6. Okay. You can see right away that DC and AB are not congruent, but we have two sides that are congruent. That will be DA. So the idea here is to see the AD is congruent to CB or BC. Okay. Therefore, guys, the rest is easy. Once you get that, then you can really see that all we have to do. See this one. Okay, so before I go any further, you need to see that these two sides are not congruent. This one's yes, but not those ones. So all we have to do is put 80 equal to that, and that's it in that situation. So 80 will be 4x. Oh, sorry. Let me see if I can get that. Yeah. Okay. So I got 4x plus 5 is equal to 5x minus 6. Okay, and we will just do the math. And if we do the math, let me see. If we were to do the math, let me see, we will subtract negative 4x to both sides, negative 4x. And we end up with 5. Sorry, let me just go over here. 5 equals to 1x, or yes, x minus 6. And then I'm going to add plus 6 to both sides, plus 6. And I end up with x equals to 11. Yeah. Okay, so we prove the x equals to 11. So that's one way. As soon as you see that, guys, you can identify if you got two an isosceles. This will be an isosceles trapezoid because dA is congruent to 5x, and you can prove that that is the case in this situation. Okay, then we have a really unique situation here. I'm going to go to example 3, if you let me. Okay, and that's finding. This is one of another reason why it's so cool to actually be able to do something like this. Let me see if I can make this just smaller so I can include that one as well. Okay, let me see. Let me see if I can make it smaller. Yeah. Okay, no, one more. Okay, so let me, yes, there it is. And I'm going to, so we can do both. We can snip it. Okay. And let's work on example 3 and example 4 at the same time. They're basically the same thing, okay? But they're a little bit different, so I want to make sure that we concentrate and learn how to do this properly. Okay, in figure, see, there we go. In figure UR, UR is the segment, is the mid segment, and that will be this line right about here. Can you see? I hope you can see it right there. That's the segment, okay? The mid segment, PQ to UST. Find UR. They want us to find the length of UR, okay? So please notice that we will add PQ. PQ it will be, let me see if I can get that. PQ will be 11 and TS will be 18. See, can you see that? So I have 1/2 of 11 and 29, right guys? So a half of that, the length UR will measure exactly 1/2 of 29, which would be 14.5. There it is. Very simple, guys. And we need to get that into account. That's all you do. You just take half of that. Okay, now let's go up here and let's try to do example 4. Again, this time they give us the mid segment, guys. They do give us this mid segment. What is the value of X? And you guys say, oh my gosh, I do not know. I do not know. So what you got to do here is say, well, they gave us one base. So you're going to say, okay, 1/2 of X plus 16.7 is equal to 24, right? Can you see that? So I need to add. So how I came up with this is with the fact that I needed to see that if I added the one base, which was X, and then I added the small base, which was 16.7, to get the mixed segment, guys, I had to multiply it by a half. That's how I got that. Well, I know the mixed segment. I need to find the long leg right there. And so the best way to do this, guys, is to get rid of that half right there. So I want to multiply both sides by 2. So I want to get X plus 16.7 equals to 48. Okay. I'm going to subtract. Now I'm going to subtract 16.7 from both sides. And I'm going to cancel this out. And I'm going to get X equal to, let me see, what do I have here? 48 minus that, it's going to give me something, I think it will be 31.3, I think. I don't know, guys. So I'm going to use my dandy calculator because sometimes it's helpful. Okay. Let me see if I can get my dandy calculator. So I'm going to go 48 and I'm going to subtract 16.7. And I get, hey, 31.3. Okay. So we were right on track. So this is 31.3. Because if I was to add those two together and divide it by half, it will give me 24. And there you are. Okay. Isn't that cool, guys? I hope you enjoy this, and this lesson is real fun, guys. Thank you so much for your attention. You can follow and do the rest of the example, but it's the same thing. As long as you remember that we're in business.